What is Kubernetes? Before we get into what Kubernetes is, let us examine why you would want to use it. Tools like Docker make it easy to create and deploy containers. Most developers or cloud administrators can easily manage applications deployed to a few servers. But what if you need to scale up quickly to perhaps dozens or hundreds of servers? How are you going to manage that? This is where Kubernetes comes in. Kubernetes is a platform for working with containers. At its core, Kubernetes gives you an easy method of deploying container applications, scaling your infrastructure up or down, and monitoring applications and servers. Let us take a closer look at how Kubernetes accomplishes all this. There are a number of architectural components to Kubernetes, but here we will discuss only two. The first is the Kubernetes master node, which provides cluster services. The fundamental premise behind Kubernetes is that we can enforce desired state management. That means we can feed the cluster services a specific configuration, and it will be up to the cluster services to deploy, scale, and monitor that configuration in the infrastructure. The Kubernetes API is the front end of the Kubernetes cluster services control pane. The API exposes all of the cluster services for your infrastructure. The second building block is the worker. A worker is a container host. Your infrastructure can have one or many workers. Each worker has a kubelet process that is responsible for communicating with the Kubernetes cluster services. So the cluster services and the workers make up the Kubernetes cluster. In this example, we want to feed the configuration to the cluster services. The configuration is defined in the YAML deployment file, which specifies the desired state for the cluster. We have named the deployment file application1.yaml. The YAML file can contain a lot of configuration information. Here, we will focus specifically on two fundamental pieces, the first of which in this deployment file is the pod configuration. A pod is the smallest unit of deployment in Kubernetes in terms of the Kubernetes object model. In a pod, one or more containers can be running. To run a pod, we need to specify a container image. Farther down the line, we can specify other things like what TCP port to use and what services are running. We can also specify how many pods need to be running. We can also list additional pods. The deployment file is fed to the API, and it will be up to the cluster services to figure out how to schedule pods in the environment and make sure that we have the right number of replicas. The configuration now has pod 1 replica 1, pod 1 replica 2, and pod 1 replica 3. In addition, we also have pod 2 replica 1 and pod 2 replica 2. At any given time, the cluster services are responsible for making sure that the configuration is running across all container hosts. So what happens if we lose a worker? Now the running configuration does not match the configuration file. It's up to the Kubernetes cluster services, through the kubelet process, to understand what is actually running and to provide notification. With P1R2 unavailable, the scheduler has to make a decision on where to instantiate that. So it will pick the best worker to host that pod and run it there, which maintains the desired state for this deployment. What we've seen here is a high-level look at some of the container orchestration services Kubernetes provides. In this module, we will look at Kubernetes on VMware Integrated OpenStack, focusing on the specific architecture, deployment, and management of container applications.